Okay, access modifiers. So far, you have seen me declaring classes and their members with the public keyword. Public is what we call an access modifier. In C# we have totally 5 access modifiers: public, private, protected, internal, and protected internal. In this lecture, I'm going to talk about public and private, and we leave the rest to when we get to the lecture about inheritance. So what is an access modifier? An access modifier is a way to control access to a class and or its members. Now you may wonder, why do we need to control access to a class or its members? The reason is to create some kind of safety or guard in our applications, to improve the robustness. In the lecture about fields, I explained how we can use the read-only modifier to make sure that a field is assigned only once, and this way we developers will not accidentally create bugs in our code. Take a look at this example. Here I've declared a customer class with a name field that is declared as private. With this code, when we declare an instance of the customer, we cannot access the name field. So we cannot go john.name. That will not compile. Now you may wonder, why do we need something like that? Well, that's the beginning of object-oriented programming. In object-oriented programming, which is actually one of my absolute favorite topics, we have 3 major concepts: encapsulation, which is also referred to as information hiding, inheritance, and polymorphism. In this lecture, we're going to learn about encapsulation. And throughout this course, we'll see more examples of achieving encapsulation. We're going to leave inheritance and polymorphism to the later section in this course. Let's start with encapsulation. I want to use an analogy. Think of a restaurant. In a restaurant, we have several roles. We have a cashier, we have a manager, we have a chef, we have 1 or more kitchen hands, we have 1 or more waiters or waitresses, and all these roles collaborate together to provide an amazing experience for you. Well, hopefully, because sometimes we go to a restaurant and we come back very disappointed. But anyway, think of the interaction between a waitress and a chef. A waitress takes the order and passes it to the kitchen. Then the chef looks at the order and does his job, and when it's ready, he notifies the waitress. So that chef is responsible for a few things, which is outside the responsibility of the waitress. A waitress is not going to go to the kitchen, tell the chef how to chop the vegetables and how to cook the meat and I don't know about different spices. Each of these roles are responsible for their own things. They have some knowledge and some capabilities. They perform some functions. Software should be the same. In software, we don't have a chef or a waitress, but we have classes, and these classes collaborate to perform the functionality required from the application. Now, we want to design our classes such that each class is responsible for one thing. It does only one job and does it perfectly. We want our classes to hide some of the information about how they do the things they are responsible for. We don't want other classes to know about the details of other classes. And this is what we call encapsulation. So we want to encapsulate some data in terms of fields, as well as some behavior or functionality in terms of methods in classes, and we want to hide the details from the outside. So when it comes to fields, we want to declare them as private and provide methods that would give access to these fields. We call these methods getters and setters. And these methods are going to be public. So we think of fields as the implementation detail, which should be invisible from the outside. It's how a class stores something in memory. We don't want any other classes to know anything about that. So to show you an example, here we have a person class that has a name field that is declared as private. So with this code, if we create an instance of the person class, we cannot access the name field of that object. Instead, we need to call one of the methods here, setName or getName. Look at the setName method here. The interesting thing about this method is that it does a check before assigning the name field of the person. So if the value that is passed to this method as the argument is null or empty, it's not going to set the name field. And this is one of the advantages of providing setters and getters. We cannot achieve the same thing with a field. A field is purely a storage in the memory. It doesn't have logic. With a setter or a getter, we can have some logic when accessing that field. Okay, before we start coding, I just need to emphasize something here. In terms of naming convention in C#, we have two naming conventions. One is called Pascal case, the other is called camel case. With Pascal case, the first letter of every word should be uppercase, like the person here, or name, or set name. Note that the first letter of every word is uppercase. With camel case, the first letter of only the first word is going to be lowercase, but the first letter of every word after that is going to be uppercase. An example of camel case is the name parameter here. So the first letter is lowercase. Now, when it comes to classes, we need to use the Pascal case when naming the class or any of its methods. For fields, the convention is to use the camel case prefix with an underline. So we need to change the name field here to something like this. So private fields should start with an underline and they should follow the camel case. Okay, I think that's enough theory. Let's start coding and see all these concepts in action. Okay, let's declare a class called person. And now we can declare a field called birthdate, which should be of type datetime. But we no longer are going to declare a field as public. Instead, we're going to use private. So private datetime birthdate. Note that I have used an underline here and camel case. So the first letter of the first word is lowercase. Now with this code, we cannot access the birthdate field outside the person class. So if we go to the main method here and create a person object, person dot, see, we don't see the birthdate field. It's hidden from the outside. And that's what we mean by information hiding in object-oriented programming. Okay, then how do we set a birth date? For that to happen, we need a method. So let me remove this for now. Back in the person class, I define two methods, public void set birth date, and this method takes a parameter of type datetime, and we call it birth date. At this point, if there are any logics around birth date, we can implement them here. In this case, we're going to keep things simple. We don't necessarily need the logic around birth date at this point. So what we need to do is simply set the birth date to the value passed to this method. And we declare another method, public datetime get birth date. And this method simply returns that birth date field. Now with these two methods, we can go back to the main method here and say person dot set birth date. We can say new date time 1982-1-1. And of course, we can read the birth date. So console.writeLine person.getBirthDate. We can run this application and we got the birth date on the console. Okay, I know what you're thinking. You probably are confused why we changed the access modifier for birth date to private, but then gave two methods here that directly modify the field or return this value. How is it different from directly going to that field? Well, if that's what you're thinking, it's in fact a good question. That's one of the questions I also had when I started with object-oriented programming. The answer is objects are about behavior, about what they do. Their fields is primarily their internals, their implementation detail, which should be hidden from the outside world. Even though in this example, it doesn't really make a difference whether we had a public field or a private field with two methods. But from an object-oriented perspective, we want to follow the principle of encapsulation, which suggests that objects should hide their implementation detail and reveal what they can do, as opposed to how they do what they're supposed to do. With the examples I will show you throughout this course, you will realize the importance of this concept more and more. Well, that's it for this lecture. What I want you to take away from this lecture is we're going to declare our fields as private, and the naming convention is underline and camel case. In the real-world applications, we are not going to define two methods like the ones you see here. This was purely for demonstration, and because I want to take things in a step-by-step fashion. In the next lecture, I will show you an easier way to achieve the same functionality, and that's what we call properties. I hope you enjoyed this lecture, and thank you for watching.